All right, hi guys. So this is the walkthrough for the circles vocabulary and arc length and sector area worksheet. So the first worksheet from this week. All right, so we're simply we have two questions here where we have to name some of the parts of a circle. So we're going to kind of go through the first one, and then I'll let you guys do the second one on your own here. So we have a chord. Right, so if we watch the notes video or just Googled it, we know that a chord is a segment whose endpoints are on the circle. So we actually have three different chords drawn in here. We have MQ would be one. Right, it's a segment whose endpoints are on the circle. So MQ would be a possible chord. We also have QN here. It's a segment. It's got two endpoints that are on the circle. QN. And then we have MN. It's also a chord. Okay, it's got endpoints M and N, and it's on the circle. So M, N. Right. Next is radius. So a radius goes from the center of the circle to the circle itself. So if we recall, the circle is the infinite number of points that goes around the center at the same distance. So radius goes from the center to the circle. So we're going from the center to the circle. Okay, so it's endpoint in the center and endpoint on the circle. So ON would be a radius. Okay, we also have OP would also be a radius, goes from the center to the circle. Okay, and then OM as well. So there's three radiuses shown here. Okay. Diameter is essentially a chord that goes through the center. So it's a segment whose endpoints are on the circle and goes through the center of the circle. So it's basically the chord, a chord that goes through the center. So MN would be our diameter that's drawn in here. Okay, central angles. So angles whose vertices are the center of the circle. So we have angle POM would work. POM. Right, you also could do PON. Right, there's another central angle. The vertex O is the center of the circle, so any of the angles that you have are going to have O in the middle. Or you could also do the 180 one here. So MON. Right, and then you could also do the big one here. So you could, if they're more than 180, you would have double. But there's no real way to distinguish the names between those two. Right, but there's three central angles, possible central angles. Okay. Then we have arcs, so major arcs, minor arcs, and semicircles. So again, if it's half, it's a semicircle. If it's less than half, it's a minor arc. If it's more than half, it is a major arc. Okay, so let's start with minor arcs here. So an example for a minor arc might be PM. Okay, so you could have minor arc PM. Right, you could also have done MQ. Right, MQ is a possibility. Right, you could have done QP. Right. Right, you could have done QN, PN. Right, those would have been your minor arcs. Okay, your major arcs are going to be more than 180. So anything that's going to go more than, I'm sorry, it's not segment, it's arc MQ. So it should have the arc symbol above. Okay, so let's look at a major arc. So major arc's going to be more than 360. So I'm just going to go, more than 180. So if you go 180 around, right, and then you keep going, right, that's going to be major because it's more than 180. So MPQ, right, we can name that MPQ. Okay, you're going from M to Q through point P. Right, we could have named that MNQ, that's the same arc. Okay, an example of another major arc might be PMN, right? So we could go P M to N. So there would be that one. And you could do a bunch of other ones. M N P would work. P N Q, right, would be another one. You could do P and Q, right? That would work. Anything that's greater than 180. All right, and then semicircles are 180. So I think it was a whole bunch of different colors. So if we do kind of a dark red here, right? So you look for the diameter, right? And halfway around, right? There's halfway around. So we'll name that MPN, right? We're going from M to N through P. Okay. And then you can also then go the other way. So if we go this way, from M to N, we're going through Q. So QN, right? Two different ways to get from M to N. There's your two semicircles. Okay. Right, and then we'll let you do the next one. So again, diameter, you have a point of tangent. Okay, so this one has some different things that weren't on the first one, the tangent line and then the secant line. So the secant line is the line that's going to go through the circle and intersect at 2 points. The tangent line intersects at 1 point, right? So you're gonna have to figure out which one are the which one's the secant line, which one's the tangent line, right? Tangent line intersects at 1 point, so it's going to end up being BJ here or BH, right? And the point of tangency is the point where it touches the circle, so that would be H. And then your secant line would be CD, right? Or BD, right? However you want to name it. Okay, so the secant line intersects the circle at 2 points, tangent line intersects at 1 point, and the point where it intersects is called the point of tangency. All right. So that's the first part, the circle vocabulary. The second part is simply the arc length and sector area. So these are all, there's 5 of each, and they're pretty much the same. So let's just do one of each on here, okay? Because it's just getting you used to the process. So if we zoom in a little, so we have more room to write, we want to find the arc length. Okay, so our arc length formula, right, was x over 360 times our circumference, right? The part of the circle times the circumference, so times 2 pi r. Right, 2 pi r is the length around the whole circle, but we don't want the length around the whole circle. We only want the length around part. Okay, so the part of the circle we're looking at is the 120 over 360. All right, we're looking at just a third of it. All right, 120 divided by 360 is going to be a third. Okay. All right, and then 2 pi r. So 2, that's our circumference. So 2 times pi, and our radius is 11. Okay, 11 times 2 is 22, so that's 22 pi. All right, so basically here, our circumference is 22 pi. That's the length around the whole circle, but we don't want the length around the whole circle. We want the length around part of it, right? We know the measure of the arc is 120, right? It's 120 degrees out of 360. That's how we got the 1/3. And now we have to multiply it by our circumference to find the length of that arc. So 1/3 times 22 pi. So we can put that in our calculator, 22 times pi, and then divide by 3, or multiply by 1/3. 23.04. So let's just do 23.0 to the nearest tenth, right? So 23.0. And that's going to be inches. Right? So just to clarify exactly what's going on here, if we do 22 pi, that's 69.1. So the distance around the whole thing here is the circumference. That's 69.1 inches. But we didn't want the distance around the whole thing. We only wanted this distance here. So that's 120 degrees out of 360. So that's 1/3 of the circle. So 1/3 times our total length around gave us 23 inches. So it's 69.1 inches around the whole thing, but only 23 inches around this part. Okay. Again, 2, 3, and 4, you're doing the same thing, except our central angle is 300 degrees, and our radius here is 15. Radius is 8, central angle is 270. Central angle is 270, radius is 14. Central angle is 120, and radius is 9. So you're doing the same thing there. All right, and then the last part, you have 5 questions on sector area. And again, this is just to get you used to the procedure, the process. So our sector area formula was x over 360, right? The part of the circle times the area of the circle, which was pi r squared. Right, so we aren't looking for the area of the whole thing. We're looking for the area in this bold region. Right, so we're looking for the area here. So the area of the whole thing is pi r squared, but we only want part of it. Okay, so we're going to do our central angle over 360, right? We want 270 degrees out of 360. Right, that's going to end up being 3/4. Right, so we're not looking for the area of the whole thing. We're looking for the area of only 3/4 of it. Right, and then our pi r squared, our radius is 10. So that's going to be 100 pi. Okay, so our area of the whole thing is 100 pi, but we don't want the area of the whole thing. We want the area of 3/4 of it. So we do 100 pi times 3/4. So that's basically 300 pi divided by 4. Which is going to be 2, and they want us to round to the 10th place, so that's 1 decimal, so 235.6. 2. Right, and then that's going to be miles squared. Right, we're dealing with area, so the units are squared, right? 10 miles times 10 miles is 100 miles squared. So you really have 100 miles squared times pi times 3 divided by 4. Okay. So again, the area of the whole thing is 100 pi, which is 314 miles squared. Right, so 314 miles squared is the area of the whole thing, but we don't want the area of the whole thing. We only want the 3/4 of it. Right. And then the next problems, again, same thing. So you got 4 more, and it's just to get used to the process. It's the part of the circle you have times the area of the whole circle. The fraction of the circle you're looking for times the whole thing. Right? And you got your central angles, and they want the part inside this bolded region. Right? And that's the first worksheet. So fairly straightforward.